Hi, my name is Joanna Klicka, and today I'm going to be going through homework 5, part B. B1 says, write the balanced reactions for production of isopropanol from propylene in water, as well as the dimerization of isopropanol to diisopropyl ether. So our equations are propylene, C3H6, plus water, yields isopropanol, so that's C3H7OH. So we'll call that reaction 1. And then we also have from there our isopropanol yielding our ether. So we have C3H7O, C3H7 plus water, which we'll call reaction 2. So moving on to part B2, it says, given pure propylene and water feed flow rates of 195 moles per second respectively, and mole fractions of propylene, diisopropyl ether, isopropanol, and water of all of that and all of that, which we'll go through in a second, in the ether and alcohol product streams respectively. Calculate the molar flow rates of the ether and alcohol product streams, as well as the extent of the two reactions producing isopropanol and diisopropyl ether. So, what we have is our system, which we're just going to represent by this box with two inflows and two outflows. So we have propylene here as one inflow at, it said, 100 moles per second. And then we have our water at 95 moles per second. Just going to double check that that's correct. 195, perfect. And then we are going to say that these are pure inflows. So we have 1, 0, 0, 0 of everything else. Then we have 0, 0, 0 of everything else, and 1 for water. And then for our outflows, we have our ether product and our alcohol product. And we are given these compositions. So we have 0.001, 0, 0.9, 0.009, and 0.01. And then for alcohol, we have 0.001, 0.01, 0.94, and 0.049. So there you have it. And then over here, I'm just going to write down the order that we have our compositions in so that we don't forget. And this goes from most volatile to least volatile. So at the top, we have our propylene. Then we have our ether. Then we have our alcohol. And then finally, our water. So now we have our 4 unknowns. So we're asked to find the molar flow rate for the ether product, the molar flow rate for the alcohol product, the extent of reaction 1, and the extent of reaction 2. And then we also have 4 equations that relate the inputs and the outputs, and this is based on the number of components, which is 4. Now that we have all of this laid out, we can go ahead over to Google Colab to actually solve for these unknowns. The first thing that we need to do is steal this from our GitHub site and paste it into our code. Then we need to import our library, so import numpy as np. And then from scipy optimize import root. And now we just have to input all of our givens. So first we have the alkene flow rate, which was 100, and that was moles per second. Our alkene composition was np dot array was 1, since our alkene is first, and then we had none of the other compounds there. We had the water molar flow rate, which was 95 moles per second, and then we had the water composition, so that was np dot array. Then we had the opposite, since water comes at the end, and that was the only compound there. Then we have the ether composition, which was 0.001, 0.9, 0.009, and 0.01. Then we had the alcohol composition, p dot array, and that was 0.001, 0.01, 0.94, and 0.049. So that was everything given to us initially, but we also know the stoichiometry of our reactions. And speaking of, to balance our equation, this needs to be a 2 right here, so that would help. And so when we type this out in our code, we're going to have our reactants be negative and our products be positive. So we have reaction 1 and reaction 2. So we have reaction 1 stoic is equal to np dot array. So first we have our propylene, so that was a reactant here, so that's a -1. We had no ether. We had 1 water as a reactant, and then we had 1 isopropanol as a product. Now for reaction 2, we had no propylene. Then we had 1 ether as a product. We had 2 isopropanols as a reactant, and then we had 1 water as a product. So now we should be good to move on and define our function. So this function is going to solve our equations. So our inputs are going to be the extent of reaction 1, extent of reaction 2, We have our ether product and our alcohol product, 2B. And then we have our actual equations. So first we have our feed that is going into the system. So that was our alkene. So that's our alkene flow times our alkene composition plus our water flow times our water composition. We had our reactions. So we have extent of reaction 1 times reaction 1 stoichiometry plus the extent of reaction 2 times reaction 2 stoichiometry, put 2 up here. And then finally we have our products. So we have our ether product times our ether composition plus our alcohol product times our alcohol composition. And then what we want to return is what went in, so our feed and our reactions, minus what came out, which is our products. Now what we want to do is use our root function, but we know that we're going to have to put initial guesses in, so we can go up here and say extent of reaction 1. We'll say that it was maybe 90. Extent of reaction 2, we'll say it was 10. Our ether product, so we want less of that since it's kind of a side product, we'll say 5. And then we have our alcohol product, which is what we want, so maybe we'll say that we got 100. Okay. Enter, and then we can go root. We need to put our function in that solves those equations. And we also need our initial guesses. So we have our extent of reaction 1, extent of reaction 2. We have our ether product and our alcohol product. Then we're going to do dot x to grab the results that we want. And something is wrong here. Let me make sure my negative signs are good up here. We have propylene as a reactant. This water here was a reactant, and this was our product up there. Check these while I'm at it. None of that. This was our ether, so that was a product. Alcohol was a reactant product. Okay. There we go. Now we have the right answer. So now we have the values for our extent of reaction 1, extent of reaction 2, and the amount of ether and alcohol product.